Hey, all you mathletes, let's go ahead and start section 3.4, which is another rule for derivatives. They just keep coming, don't they? So this one's going to be the chain rule. So let's look at a couple of functions and just say, or find their derivatives. So what's the derivative of x to the 7th? Well, that's just the power rule. That one's pretty easy. 7x to the 6th. Okay. B, g of x equals x squared plus 1 to the 7th power. Oh, shoot. Well, if I'm going to find the derivative of this with what I know already, I would have to expand this whole thing out and then do the derivative once all of that stuff is done, which is doable. It's just going to take you a while to do. So there has to be a more efficient way than doing all of that algebra stuff to finally just do a derivative. So there has to be a better way than expanding that sucker out. And there is indeed an easier way, and that is going to be the chain rule. So this is going to allow us to find derivatives of more complex functions. So namely, when you have like quantities involved with exponents or in an angle or inside of a radical or stuff like that, as opposed to just a single x. All right, so let's look at what the rule says. So if y equals f of x is a differentiable function of u, and u equals g of x is a differentiable function of x, then y equals f of g of x is a differentiable function of x. And the derivative of f of g of x is going to equal f prime of g of x times g prime of x. So this notation right here, you usually see this in like an Algebra 2 class or intermediate algebra. This is a composite function. So this is where like you have a function plugged into another one. So it's saying it's like the derivative of the outer function with the inner function still in it times the derivative of the inner function. So I know this is like, wait, what did he say? What on earth does that actually mean? So let's go ahead and finish this out, and then we'll actually get into how the heck this is really going to work. Because hearing it and seeing this notation is one thing, understanding how it works is another. Okay, so the derivative of f of u, remember u is some other function, is going to equal f prime of u times u prime. Okay, so eventually you're going to be able to use this chain rule and go off of just, to be able to do it right in your head. But usually in the beginning, to use a chain rule, a good technique is to utilize a substitution method. And eventually, as I said before, hopefully you'll be able to do it right in your head and you'll just be able to do derivatives really fast. But in the beginning, we're going to use a U substitution. So for the U substitution, we want to choose something for U. We want to make it equal to some function so that the given function is much simpler. Like it's a lot easier to work with and kind of get your head around. So you typically choose the stuff that's inside of something. So if you're going, what am I going to choose for U? It's usually whatever is on the inside. So like inside the parentheses, inside the radical, inside the angle of a trig function, etc., etc. So before we start calculating out derivatives, we're just going to practice choosing the u and doing the U substitution. Just rewrite the function just to get it in terms of u, just so you can see how that's going to work. Okay, so here we go. Y equals 4x plus 3 all to the 5th. So again, you're looking for the stuff that's on the inside. So let's look at the stuff that's inside the parentheses. So the 4x plus 3, so that's going to be a really good choice for you. So I'm just going to write it off to the side. So u equals 4x plus 3. So I want to change this given function and get it so instead of x variables, I have a u. So I'm going to use the substitution that I wrote down. I'm going to apply the choice that I picked for the u. So the fifth power is staying, so the inside, this 4x plus 3, that turns into u. So my function is now u to the fifth. And u to the fifth is a lot nicer and easier to kind of work with than this 4x plus 3 to the fifth. Okay, let's try it again with part B. So I'm looking for the inside. That's what I want to choose for u. So the inside is 2x minus 3. And you're choosing the entire inside. Like, don't just choose like one term. You got to choose the entire thing. Otherwise, you're not really doing a whole lot. Like you would, if you just chose the 2x, you'd end up with a u minus 3, which, yeah, it's in terms of u, but it's when you go to find a derivative, you're still going to have a quantity. So you're trying to get those quantities down to just a single variable. So you don't like quantities inside of things. Okay, so that 2x minus 3 is going to substitute out and become a u. So the equation I really now have is 4 root u. Okay, so for a trig function, the inside stuff, a lot of times it's going to be the angle to work with. So x squared plus 6x minus 1 is the u. So if I switch it out, that x squared plus 6x minus 1 becomes u. So I really have just y equals sine of u. All right, part D. For exponential functions, the inside is the exponent. So that's my choice for the u. So I'm going to switch out sine of x with u. So y equals e to the u. There's not much to do there to simplify it. I'm just going to write it all as one color. So e to the u. So that's how you rewrite a function in terms of u. So now that you've practiced that, now we can get the derivatives of those functions. So first, let's remember what that chain rule is again. And when we have it in terms of u. So it's f prime of u times u prime. Okay, so I'm going to stop the video here. In example 3, we're going to find the derivative of these functions that we just worked with from up here.